Hey guys, so today we're going to be talking about triangle inequality theorem, and it goes right along with the activity we did yesterday. You guys had those straws cut up, and we tried to use the same color straws to see if we could make triangles out of the measurements that were given, and we kind of did an exploration with that. And we kind of practiced. It was a little bit of guess and check. So today we're going to talk about the math that really is behind all that and how we can look at three measurements and decide mathematically if they will form a triangle. So our learning target for today is I can determine if three given side lengths can form a triangle. And we're going to start out by talking about actually what the triangle inequality theorem is. So it's been a little bit since we talked about that word theorem. We have seen it before, but I want to refresh our memories really quickly. A theorem is just kind of a fancy way of saying that this is a statement that has been proven. So we know it is going to work every single time. So every triangle that we see, this statement that we're about to talk about is going to be true for every triangle, no matter what kind it is. So that inequality theorem that we're looking at is the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So I know that kind of sounds really wordy. So we're going to break it down. The sum, we know that's important. We always box or underline or bubble in are important words, right? So the sum of the lengths of any two sides of a triangle, that means we're adding them up, has to be greater than the length of the third side. So what that looks like, okay, because I know it's a little bit easier sometimes when we see it. So if we have a triangle, we know all triangles have three sides. Just to make it a little bit easier, we're going to label these sides. So we have A, B, and C. Now, if I add any of those two sides, the sum that I get, the answer that I get when I add them, has to be greater than the third one. So if I do A plus B, whatever I get needs to be greater than C for this to really make a triangle. If I did A plus C, it would have to be greater than B. And if I do B plus C, it's going to have to be greater than A. So the reason that that and is there is because all three of those statements must be true. Okay, so we know for an inequality to really work, we've talked about inequalities this year, it has to make a true statement by the time it's done for it to be a real solution. So just like that, all three of these inequalities have to be true for the side lengths to make a triangle. And I know that's kind of hard to hear when we're just talking about it, so we're going to do a couple examples here in just a second and make sure that we kind of understand how we can check that out. So for our first example, we're going to determine if a triangle can be formed with the following side lengths. And the side lengths that we have are 4, 10, and 5. So if we add two of those up, it has to be greater than the third one. But that has to be true with every pair of two. So if I do 4 plus 10, just looking at those first two, it would need to be greater than 5. And then if I did 10 plus 5, looking at those second two, it would have to be greater than 4. And then the only other ones I need to pair up are 4 and 5. When I add those together, it needs to be greater than 10 for these three lengths to make a triangle. So we're going to test those out, see if they work. So looking at that first one, we have 4 plus 10. 4 plus 10 is 14. 14 is greater than 5, so we are good to go on that one. 10 plus 5 is 15. 15 is greater than 4, so we're good there. And then 4 plus 5. Now 4 plus 5 is 9. Since 9 is not greater than 10, that one doesn't work. So remember on that last slide we were talking about how all three of these statements had to be true. So even one of them can mess it up. So, and that's what happened on this one. So since that one pair did not work out, this cannot make a triangle. Now on your papers, you guys are going to practice here in a few minutes with your table partners. And when you're doing that, I want you to record these steps of how you work it out and show me that. But then you can give me a simple just yes or no, can it make a triangle? And in this case, it would be no. But I do need to see your reasoning off to the side. Okay, just like we did the check, check, X, you can give me something similar to that on your worksheet. So we're looking at example number 2. We're doing the same thing here, but our new side lengths are 12, 9, and 8. So we're going to try these out. 12 plus 9 has to be greater than 8. Same thing for the other two sets of sides. We want to check all of those. So starting up at the top, 12 plus 9 is 21. 21 is greater than 8, so we're good. 9 plus 8 is 17. 17 is greater than 12. We can check that one off. And then on that last one, we have 12 plus 8. 12 plus 8 is greater than 9, so we're good to go. On this one, all three of them work. So yes, we can make a triangle. What that means is when we're putting these together, so think about your activity with the straws yesterday. When you were trying to put them together, we had some groups that it just wouldn't reach, no matter how hard you tried. So with this one, these would all reach each other if we had straw lengths of 12, 9, and 8 inches or centimeters or whatever. We can also use the triangle inequality theorem to help us out when we're finding a missing side length. So kind of a range for them. So a triangle has side lengths of 6 and 12, and we want to know the possible lengths of that third side. So the way we're going to do this, it takes a little bit more work, but we can handle it. So I like to draw a picture to kind of illustrate what's going on. So if we have this triangle, and we know that one of the side lengths is 6, another one is 12, and then we don't know what that third side is. So I put a variable there. You guys know we use variables whenever we're trying to find something we don't know. It represents the unknown. So in this case, I still know that all of the sides, when I add two of them up, it has to be greater than that third one. So in this case, if we did 12 plus 6, it would need to be greater than x because x is the other side. That's going to be true for both of the other two. So if we did 6 plus x, it has to be greater than 12. If we do 12 plus x, it has to be greater than 6. So I want you to look at that bottom one really quickly. Now, 12 is already greater than 6 on its own. And we know that a side length of a triangle cannot be a negative number. So no matter what the length that x is going to be, this one is already going to be true since we can't have a negative. So 12 plus any positive number is automatically going to be greater than 6. So we're going to kind of focus on those other two to help us figure out the limitations for x so that we can see how small it can possibly be and how large it can possibly be. So if we look at the first one, we're going to just simplify as much as we can by combining like terms. We've done that in our previous units with equations and inequalities, expressions, all that stuff. You guys are really good at that. So we're going to go ahead and combine our like terms. We have two constants on this one. 12 plus 6 is 18. 18 is greater than x. So that tells me x has to be less than 18. If 18 is greater, x has to be some number that is less than that. But I don't know how small that it can possibly be, and that's where this other one is going to kind of help us out. So we have 6 plus x is greater than 12, and we're going to use that to isolate the variable. So I need to get rid of 6. We know we do inverse operations here, so I'm going to subtract 6 on both sides. We have to keep it balanced. So whatever we do on one side of the inequality, we do to the other. That's a refresher from a couple months ago. And then, so those are going to cancel. That leaves x on one side, and then 12 minus 6 is 6. So x has to be greater than 6. So it can be anything greater than 6. But you'll notice we have another one, right? We have two x values here. So it has to be less than 18, but it also has to be greater than 6. So we can write that all together. 6 is the smallest one of them. So that shows us that x is greater than 6, but x is less than 18. So this third side could be anything between 6 and 18, but you'll notice that we don't have those or equal to lines underneath. So it cannot be 6, because 6 plus 6 is 12. 12 is not greater than 12, okay? So it cannot be 6. It could be 6.01. It has to be anything above 6, and it cannot be equal to 18, because 12 plus 6 is 18. 18 is not greater than 18. So those are our limits here. It can be anything in between. So that includes a lot of fractions, a lot of decimals, and a lot of whole numbers too. So our third side can be somewhere between those. Now I want you guys to do a few practice. We're going to do them like our first examples. I think we'll need a little bit more practice before we move on to some of those, like example number 3. But I want you to try these on your own, and then you can check with your shoulder partner and see if you agree, and then we're going to talk about those in just I'm going to give you 4 minutes, okay? So make sure you show me your work and give me an answer on these.